Good morning, class. This is your another practical regarding the full wave and half wave rectifier, and in this we will study about the voltage regulation and ripple factor for full wave and half wave rectifier both. So rectifier's purpose is just to transform AC supply into DC. So that is why I have their diagram, that is AC supply is there for the step down transformer, and there are two diodes, two PN junction diodes. Along with that I am having a capacitor which is parallel to that diodes, and DC will be calculated at the output end. So whenever I use one diode, that will be for half wave rectifier, and when I use two diodes, that will be for full wave rectifier. So AC supply is going to be transformed into DC supply, and ripple factor will tell us that how much amount of AC is going to be into DC. So beta, this is the circuit diagram for the rectifier. Here I am having a diode here, that is for the half wave rectifier, okay, and this is another one circuit, that is for the two diodes known as full wave rectifier. Here is the step down transformer, and there is 9 voltage power supply for the input terminals of this diode, means AC supply is of 9 volt. And here at these ends we will calculate the DC current, that how much AC is going to convert into DC. So at these points I will study the DC amount. So these wires are connected to this multimeter. So here I am having AC supply, this is the sign for AC, this is the sign for DC, this is multimeter. So this is voltmeter. Voltmeter tells us that 10 voltage is there for AC, input AC. So for output I have put that knobs, that probes at these ends, that means this is for the output. So these are connected to this multimeter, and it shows that at DC point of voltmeter, it shows that DC amount of voltage is now 4.1. So AC is going to be converted into DC from 10 to 4 volt near about. So this is for the half wave rectifier. Now I will proceed for the full wave rectifier. So this is the circuit for the DC, AC to DC for full wave rectifier. So here I am having this transformer, step down transformer, AC supply is here. So 9 voltage is here for the negative half, and 9 voltage is here for the positive half. So input supply is of nearly about 18 volt. So this is connected to the multimeter so that we can calculate that AC supply is of 20 volt near about. Okay, so this is the sign for AC and this is voltmeter. So it tells us that AC supply for the input for full wave rectifier is 20. Corresponding to that, these two diodes will rectify that AC input to the DC one. So DC we will calculate at this knob. Okay, then I will put just these knobs at this point so that I can calculate the output at this end for the DC. So beta, this knob is for the output, okay, and output is now connected to again multimeter, which shows us that VDC means output at DC is equals to 9.5 volt. So this is the output. So this is how we can regulate the voltage for full wave and half wave both rectifiers, where AC supply is there at this end and DC we are going to study at this terminal. Okay, so whenever I join this input source to this terminal, at this terminal and at this terminal, then this is the ground point, 0 voltage. So that grounded point we will locate here with the negative terminal of the multimeter. Okay, so input is at these points, similar is for the half wave at these points. These are the input sources where AC is going to be supplied at these points, and output will be at this terminal. Okay, output for half wave rectifier is there and output for the full wave rectifier is there. For both AC and DC we calculate it from the multimeter. So here for full wave rectifier output is 9.8, and the formula for the ripple factor is there. So this is how we can calculate the ripple factor. Here I am having VM. VM means the input AC supply of 14 volt. Corresponding to that, V RMS means root mean square value of voltage will be Vm upon under root 2 for full wave, and for half wave Vm upon 2 will be the voltage for root mean square value, and VDC is the output voltage which will be there for the AC to convert into DC. So 2 Vm by pi and Vm by pi is for the half wave and full wave rectifier. This is how with the ripple factor formula gamma we can calculate that how much amount of AC is going to be transformed into DC supply. Thank you class.